Okay, 7.4, solving equations with multiplication and division. This is an equation. Once again, we've talked about equations for most of the year. It is an equation that has no sign right there, so this equation you're multiplying 14 times Q. Okay. Now, the inverse operation of multiplying is dividing. So, then the inverse of multiplying 14 times Q would be to divide 14 to both sides. So we're going to divide 14 to both sides. Over here, the 14s cancel out, leaving me with Q. On the other side, you're going to divide 14 into 42. 14 will go into 42 3 times. 3 times 14 is 42, remainder 0. So that means Q has to be equal to 3. So then what they're saying is 14 times 3 should be equal to 42. 14 times 3 is 42. So the two sides are equal and balanced. So they do check out. So your answer is Q equal 3. Okay, now $20R equal 100. I want you to do the same process we just did up above and solve that equation. Okay, Vivica, what'd you get? 5. Yes. So, we divide by 20 to both sides. 20 over here cancels. R is equal to 20 into 100. Now, obviously, this is just a fraction, 100 over 20. Okay? It is an improper fraction. So, therefore, since it is an improper fraction, that's why we're reducing it to a whole number or mixed number. Okay, now, let's say they put some negatives in there. So hang on here, let me finish that one out. So R is equal to 5. So if they put negatives, the process doesn't change. Okay, now I'm just multiplying by negative 3 to t. So therefore, the inverse of multiplying by negative 3 would be to divide by negative 3. Once again, this is where you've got to know your rules for negatives. I'm dividing and I have two negatives, so that gives me a positive 3 as the answer because there's two negatives. If there's one negative, it would be a negative 3. Since it's two negatives, then it's positive 3. I want you to try this one on your own. 9s is equal to negative 27. Okay, Haley, what did you get?
I got negative 3.
Yes.
Can I get a 2?
Yes. Now, to solve this, we have to divide by 9 to both sides. Cancels there, leaving with s is equal to negative 3, because we're dividing 9 into 27, and there's only one negative sign. That's why the answer is negative. Okay? Now, let's look at a harder problem. Let's say we had this. S. Negative 1.2s equal negative 6. All right, now, in this one you have to remember not only how to solve it, but you also have to remember what we do with decimals. So to solve this, we divide by negative 1.2 to both sides. It cancels on the one side where you're dividing 1.2 into 1.2. On the other side, you have this. Okay, now, we can't have the decimal outside the division bar. So we have to move it one place to the left, but we have to do the same thing on the inside. So we really have s is equal to negative 12 into 60, which 12 goes into 60 5 times, remainder of 0, and so s is equal to positive 5. Once again, the reason it is a positive is because of those two there. Anthony? Okay, you're going to have to be more specific. You don't know what 12 times 5 is? Okay. Anytime, let's say I just had 3.24 divided into 6.1. Okay, I can't do that like that. The only way that I can do that is to take this decimal and move it out of the number. To move it out of the number, we have to, in this particular number, we have to move it twice. And so that gives me 324. Well, I can't say 324 divided into 6.1 because that's not the same problem as 3.24 into 6.1. Okay, so therefore, what I have to do then is I have to take the decimal inside here and also move it 2 places to the left or to the right. And when you do that, that gets you 610. Now I can divide 324 into 610 because it's the same. Okay, it's the same problem, same answers, everything. Okay, so let's look at another one that has a decimal in it. Now, understand, here's another thing, not just for Anthony, but everybody. If it was this to begin with, that's fine. Okay? We only look at the decimal as if it's out here. The decimal inside the bracket is fine. You don't have to move it here. You don't have to move that one. Okay, it would just stay 6.1, and that would be it. Okay? All right, let's look at one more decimal one here. Negative 3.5 F equals 24.5. Okay, so to solve it, we divide by negative 3.5 to both sides. 3.5's over here just equal 1, so they cancel each other out. Understand it's not 0, it's 1. So you basically have, on the left side, you're left with 1 times F. Well, what is 1 times F? F. Whatever F is, that's, 1 times, if F is 12, then 1 times 12 would be 12. Okay? On the other side, we have 3.5 into 24.5. Once again, we can't have the decimal on the outside of the bracket, so we have to move it outside of the number. But what we do on the outside, we must do on the inside. So it must move also 1 time. And that gives me F is equal to 35 into 245. Okay. Now, 3 goes into 24 how many times? 3 goes into 24 how many times? 8 times. For those of us that remember our multiplication tables from 3rd grade. Okay. So we're going to estimate that it's going to go, that 35 will go into 245 either 8 or 7 times, because 35 is halfway between 30 and 40. So let's start with the smaller one of 7. 7 times 5, it's 35, carry my 3, be 245, remainder 0. So F is equal to negative 7. All right, I want to do one, last one, dealing with the no decimals here in this one. I want to do this one here. 3x equals, no, hang on here. 18x equal 6. Now, right away, you may think, well, 18 times what equals 6? Well, 18 times 1 would be 18. So it'd have to be lower than 1. So what we're going to look at is we're going to deal with a fraction here. Okay? But the process is still the same. The process doesn't change regardless how big or how small the numbers are. The process is still divide by both sides by the number that's in front of the variable. That cancels, giving me x is equal to, well, 6 over 18 is a proper fraction. So then all you have to do is reduce it. What can I reduce 6 over 18 by? What's common between 6 and 18? 3. Anything else? Okay, anything else? 6. 6 goes into both of them. 6 goes into that 1 time. 6 goes into 18 3 times. So x is equal to 1/3. So what they're basically saying is if I take the problem, 18 times 1/3, that has to be equal to 6. Well, 18 times 1/3 is 18 over 3. 18 over 3 is 6. So they do check. So that's what that's what happens. All the ones we had dealt with up to that point were, the top number was larger than the bottom number, improper fractions or decimals. Okay, that's what you do when you get a proper fraction. You don't need to panic. Okay, well then I must divide 6 into 18. No, you don't divide. It's the question we talked about the other day when we were talking about the cups here. We don't take and add stuff to the side that's on the variable side. Okay? Now, next type of problem. X over 6 equals 72. So what they're saying is this. Hang on, that's wrong. X over 6 is equal to 8. So what they're saying is, I'm going to divide 6 into some number, and I'm going to end up with 8. So when you divide 6 into the number, what number can you divide 6 into and get 8? In other words, what number does 6 go into 8 times? Right, 48. Okay? Now, here's how we get that. Okay? You're basically going to take, and this is dividing 6 into x. Okay, that's dividing 6 into x. The inverse of that is to multiply both sides of the equation by 6. So I am going to multiply by 6 over here, 6 over 1 because it's a fraction, and I'm going to multiply by 6 over 1 here. These two cross cancel, leaving me with x over 1 is equal to 48 over 1, which means x is equal to 48. Well, when it's all nice and pretty like this one is, yes, you can do that. But once again, we go back to you've got to know the process, because in a day or so, we're going to stick 2 things going on at once. And so if you don't know the process, you're not going to be able to do it. Nicole? Huh? Yeah, you go out in the hallway, shut the door, and be loud out there. Now, huh? No. Now, let's do a couple of these that are in the book. D over 24 equals 0.5. Okay? Now, once again, we're dividing 24 into D. The inverse of that would be to multiply both sides by 24 over 1. Well, we know that 24 over 1 is just 24. Okay? The only reason I say over 1 so you can see that these two cancel. Okay? Those two cancel each other out, leaving me with D is equal to 0.5 times 24. And this is a negative 0.5. Okay? No, because we have to multiply 0.5 times 24. Well, 0.5 times 24, I'll work it out, but it's really just 0, carry my 2. 5 times 2 is 10, plus 2 would be 12. There's one decimal place here, so I have to move the decimal one place to the left, which gives me D is equal to 12. Because half, 0.5 is 1/2. 0.5 times 24 is just basically half of 24, which means it's 12. So what they're saying is if we were to check this, 12 over 24 equals 0.5. Well, 12 over 24 is a half. Is a half equal to 0.5? Yes, they're exactly the same. So that does check. All right, now, the last type of equation we're going to look at a couple of them, but is this one here. 4/3 times t equals 12. Okay. Nope. Now, there is a special rule for these types of equations. The rule is this. When you have a fraction sign in front of a variable with no other sign in between. Okay, is that the case here? Is there a sign in between the fraction and that variable? Yes or no? No. No, there's not. I'll answer it for you. There's not a plus, there's not a minus, there's not a division sign. So, to solve this type of equation, you must multiply both sides of the equation by the reciprocal of the fraction. Actually, it's not a fraction sign. Just mark that word out. So you're dealing with positive and negatives right now. Just everything's a sign. Okay, so let's reconsider that one that I wrote. 4/3 times t equals 12. So to solve this, multiply both sides of the equation by the reciprocal of 4/3, which is 3 over 4. Okay, so I have to take and multiply both sides, time the reciprocal, to solve it. Now, all this cross-cancel, leaving me with t times 1. Okay, well, we've already said that that's just the variable, in this case, t. This right here is 12 over 1 times 3 over 4. We can cross-cancel here. 4 goes into 4 once. 4 goes into 12 3 times. So that leaves me with 3 over 1 times 3 over 1, which means t is equal to 9. Now, the reason that you multiply by the reciprocal, okay, the reason we multiply the reciprocal is this. If you have a fraction in front of a variable, it means to do what mathematically? Multiply, divide, add, or subtract. Huh? There's a fraction in front of the variable and nothing else. Multiply. So the inverse of multiplication is what? Division, right? So if we think back, if I have, for example, 5 divided by 4 over 3, okay? Some of you have probably forgotten this. I have no doubt that you have. When you divide by a fraction, then we do this. We change the division to multiplication, and we do the reciprocal of the second number, which is 3 over 4. Okay? That's the reason, since we're solving, that we just go ahead and multiply. In other words, we go ahead and do this step right here. Okay? Instead of working all that other out and then having to show all those other steps, we just remember the rule that you have a fraction in front of the variable. To solve, you multiply by the reciprocal. Okay, I want you to try this one on your own. The negative sign does not change the process. Does anybody have an answer for me? Okay, keep working at it quickly. Shouldn't take you that long if you're following the process. All right, continue to work. y is equal to -7. Well, that's the only way you can get it every time. Now, it may have worked on this time, but it doesn't. What did you do? Okay, you just said that's the same thing you got, but you didn't do it that way. So how did you do it the same way I did? I did it the exact same way that I was teaching you.
I did it the way that the other ones do, like these. Over here.
So how did you do it that way?
I divided 5 into 30, or 35.
So what'd you do with the 7?
I just put
So you just put divided by 5 and then just put a -7. You can't do that. Can't do that. All right, your homework is this. 7.4, 2 through 11. We will work on the rest of it in class tomorrow. The rest of this section, not that homework.